All right, so we're moving right along in Unit 10. So far, you've learned how to name your polynomials, add them, subtract them, multiply different types of polynomials. And so in the next lesson here, section 10.4, we're still going to talk about multiplying, but we're going to talk about multiplying special polynomials. So your title says special products. I'm saying products because product we're multiplying, so that's your result. When you multiply, your answer is a product. But I want to just kind of introduce you to some of the special looking polynomials. Now, to summarize everything I'm going to say, pretty much I could tell you, if you don't recognize the patterns that I'm about to show you, just do it the regular way, the box method. You'll end up with the same answer. But if you do recognize the pattern, all you have to do is apply the pattern and then you're done. What I'm going to show you today is just some shortcuts that may save you a little time. So the first special polynomial we're going to talk about is the square of a binomial. Okay, so let's break this down. I know that you know that binomial, or hopefully you remember that binomial means two terms. So when we're talking about special cases, we're only dealing with polynomials with two terms in them. Okay. Now the word square, what we're talking about is the exponent. All right. So we're talking about that we're pretty much just going to take a binomial and we're squaring it. Now there's two forms that you'll see the special case in, and hopefully it will be what triggers your mind to say, oh, this is a special case, which means I'm going to get a special product, which means I can use the shortcut if I recognize the patterns. So the first general form is A plus B quantity. When I say the word quantity, that means that's the parentheses squared. All right, so two binomials, and like I said, I'm using A and B, but you know that it could be, AX plus 5, 3X plus 2, whatever. And what happens here is that when you're squaring the binomial, it's the same as saying, and you don't have to write this down, just watch. This is the same as saying X squared. We know that X squared is X times X. Or if I said I want to say 3 squared, we know in our mind what we're really doing is just multiplying 3 times 3. Well, you got to do the same thing with the binomial. If there's a binomial that's being squared, that simply means it's that binomial multiplied to itself. Same with if we're subtracting. A minus B quantity squared is, if you extend it, or you'll learn in Algebra 2, we say expand out, that's A minus B times A minus B. It's A minus B times itself. So here, once you expand the square of a binomial, you have the same thing that we had when we were just using the box method, when you're just multiplying two binomials, okay? Now, what I need you to understand, and you see there under number 2, you need to realize that when you see a quantity that's raised to a certain power, and in this case we're squaring, it is never A squared plus B squared. No, no, no. This is a no, no, no. You cannot do that. So put that in the blank. You never just square the terms. You have to extend it out. So I'm going to pinch whoever I see doing this on homework and mastery checks. All right? Now, in the next video, we're going to take some real examples of binomials, use the box method, and hopefully after we see a few of them, we'll recognize the pattern.